Recall that in Excel, it's a relatively simple matter to right-click on a cloud of data points and have the computer fit a line to the data points. Now you can also tell Excel to give us two things. One is the equation of the line of the form y equals mx plus b, where b is the intercept. The second thing is the r squared, or the explained variance. It tells us how much of the variability in y is explained by the variability in x. Now, the problem with this is this slope, this rise over run, is just a point estimate. In this case, it says, for every unit increase in fly ash, we should expect a 0.044 increase in compressive strength. But what it doesn't tell us is how certain we should be about this relationship. When we go to our boss and say, this is the impact of fly ash on compressive strength, we're not just talking about our one little sample of experiments. We're talking about universally the relationship between fly ash and concrete, which means we're talking about the population of data points, not just this small little experiment we've done. So what we really need to do is take into account the fact that there could be sampling error, that if we took a different sample of concrete and did a different set of experiments, we would get a different estimate of this slope, this rise over run, this coefficient. So what we really want to do is have some confidence intervals around that estimate. We also want to assess the probability that the slope is zero. Now, a zero slope means that on average there's no relationship between our x variable and our y variable. This is precisely what we get if we run a linear regression from within Excel or use a specialized statistics package to run a regression. So here's the output, and you can ignore most of the complexity for now, but we'll see a few familiar items. First of all, up at the top, we see the r squared, which is exactly the same as it was when we simply fit a line. If we go down, we see the coefficient. Both the intercept and the coefficient are exactly the same as they were in the previous slide when we had the equation. But what linear regression gives us above and beyond the equation for the line is it gives us some confidence intervals around that slope. Now, in this example, both the coefficients, the lower bound and the upper bound, are positive. But imagine what happens when we get a lower bound that is negative, an upper bound that is positive. What this tells us is that we cannot be sure that the slope is different from zero. Indeed, this is one of the most intuitive interpretations of the p-value provided here in the table of coefficients. The p-value can be interpreted as the probability that the coefficient, that is the slope of the line, is zero. Now in this case, the probability is extremely small, 10 to the negative 5, which confirms what we knew already because our confidence interval does not include zero. In this lesson, I'm going to use Microsoft Excel to do a single regression. Now it's a single regression because we're going to use a single explanatory variable, in this case fly ash, to predict or better understand compressive strength. So to do a regression in Excel, we hit Data and then bring up the Data Analysis Tool Pack, and we'll see there's an option for regression. So click OK, and now we have to be very careful when selecting our ranges. So the Y range is our response variable. So I'll click the label, Shift N down, and then for my X range, I'm going to select fly ash, just one column here. So the label, Shift N down. Now because I selected the labels, I want to make sure I tell Excel that I selected the labels. And normally I ignore this confidence level, but I'm going to put 99% in here. And the reason I'm going to do that, as you'll see in a minute, is by default Excel gives you 95% confidence levels. So if we leave this blank, we get two sets of 95s. So I'm going to put 99 in so I can see the 99s. Finally, I want to tell Excel where to put the output tableau. Now here you have to be very careful because as you see, the focus has shifted up to the Y range. You have to click here to make sure that the focus is in the right spot before you click on a cell. This is a bug that's been in Excel for years and years and years, and it's very annoying because you often end up clobbering your response variable range. Now down at the bottom here, there's a whole bunch of other stuff about residuals and stuff like that. We can ignore that for now. I'm just going to hit OK and then scroll over and maybe resize a little bit. And there we get the tableau, just as before. We get our R squared, and we get what is essentially the equation of a line in the table of coefficients. Now you can also see, if we just resize these, that we get two sets of confidence intervals, 95 and 99. And not surprisingly, the 99 are wider because we are 99% sure that the true value lies between a wider range.